This video is about percentiles. So first of all, what is a percentile? Right, percentiles are measures of location. Okay, so say I have 100 values and they happen to be 1, 2, 3, 4, 5 all the way to 100. And all the way, let's say in the middle I have like 49, 50, and so on, 99. Okay, so I have 100 data values, and percentile are denoted as P1, P2, P3, all the way to P99. And these percentile notations are dividing your data into 100 groups, and so you will have 1% for each group. So P1 will be right here, right at this location. P2, P3, P4. So here will be P50 and so on, right? This will be P99. So if you have 100 data values, P1 through P99 will, divide one number in each, group. So how do we find the percentile of a specific value in a data set? So take this data set, for example. Say I want to find the percentile. Let me pick a number. Let's say I want to find the percentile of this number, 14.2. Okay, so first of all, you want to count how many numbers there are less than 14.2. So how many? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each line is 10. So 20, 1, 2, 3, 4, 5, 6. So there are 26 values that are less than 14.2, right? Divided by the total number of data values. So here we have 10 on each row, and we have 5 rows here divided by 50, and multiply, since it's percentile, right? Cent means 100, so you need to multiply by 100. So somehow you're converting the position of 26 in 50 into 100. So you will have, if you do the calculations, right, this is 2, 1, so that's 52. So the percentile of 14.2 is the 52 percentile. So I can say P52 is 14.2. Okay, you should read it as the 52nd percentile. Now let's see how to convert a percentile to a data value. Say we use the same set of data here. Okay, now I want to find what is P45. Let me call this question A. And my second question is find, let's say, P30. Okay, first we need to find something called the locator. Basically tells you where the data P45 is at, right? So it's called locator. We use the formula L equals K divided by 100 times N, where this K is the percentile you're trying to find. So this K in our case is 45 divided by 100 times the number of data value. We already know it's 50. Alright, so if you do, you do the calculation, 1 is here, 2 is here, So 45 divided by 2, that's 22.5. Okay, since this is not a whole number, we round it to the next integer. In this case is 23, right? It's not because it's 0.5, so I'm rounding up. Even though you have 22.3, for example, you will round it up to 23. You round it to the next integer, next larger integer. Okay. So this 23 tells you the 23rd largest number is your P45, so you will count. So here each row is 10, right? So 21, 22, 23. This will be P45. So it's 13.1. So P30 is pretty much the same, a little bit different. So first still we want to find the locator L using this formula, K divided by 100 times N, where K is the percentile you're looking for, which is 30, divided by 100, and in total we have 50 data values. Then do the calculation. So since the answer is 15, which is a whole number, you will look at the 15th value and the next value, which is the 16th value, and you will add them up and divide it by 2. So the 15th value is, let's see, 11th, 12th, 13th, 14th, 15th is here, 16th is here. So you will meet in the midway of 15 and 16. That's the P30. So that's 10.2 plus 10.3 divided by 2. That will be 10.25. So P30 here is 10.25. So that is percentile. There are quartile. So quartiles are also measures location. They actually divide your whole group of values into 4 groups. Each group takes like 20% of the values. So you have Q1, Q2, and Q3 actually. So you have the bottom 25%, right? So it's from 0 to 25%. And then you have from 25% to 50%, that's Q2. And from 50% to 75%, that's Q3, right? So Q1, Q2, Q3 divides all your data values into 4 groups. Each takes 25%. So as you can tell, Q1 is exactly the same as P25. And similarly, Q2 is exactly the same as P50, which is the same as the median. It's the number right in the middle. And Q3 is equivalent to P75. Okay, now I will introduce what is called 5-number summary. Okay, 5-number summary includes the following 5 numbers of a data set. First is the minimum. Next is the first quartile, Q1, then the second quartile, which is equivalent to mean, right? Then the third quartile, and then the maximum. So these 5 numbers in the data is the 5-number summary. You can always convert a 5-number summary into something called a box plot. So now say my minimum is 10, my maximum is 100, and my Q1 is 15, my Q2 is, let's say, 80, and my Q3 is 95, for example. Okay, so how do I construct a box plot out of these 5 number of summary, right? Okay, so first let me mark those numbers on a number line proportionally. So if my 10 is here, so 10, 20 would be here, 30, 40, so here will be 0, 50, 60, let's say 70, 80, 90, here's 100. Right. So my minimum, it's right here. Right. So it's 10. I'll mark it here. And my Q1 is at 15, which is right here. Q1. Okay, so it's 15. So I'll call this minimum. Q1. And then my next Q2 is around here. 80, right? That's my Q2. And Q3 is 95. Right here. That's where my Q3 is. My 100 maximum is 100. And this is how you draw your box plot. For Q1, Q3, Q2, Q3, you draw a box. And then, there you go. That's the box plot for this set of data, showing the 5-number summary. Now, if we're given a set of data, how do we draw a box plot? Right, one way is you find the 5-number summary by hand. You find the minimum, maximum, and calculate Q1, Q2, Q3, which is P25, P50, and P75, and then construct a box plot. This is one way. Another way is you can use StatCrunch to help you construct the box plot. So first you open StatCrunch and put your set of data over here. I will just make up some numbers. Let's make up to 10 data values. So I will go 56. Next I will do 98, 40, 92, and 87, for example. So I have 10 data values. I want to draw a box plot about this set of data. So you go to Graph, here's Box Plot, click here, select the column, it's variable 1 in our case, and here you want to select this one, otherwise your box will be drawn vertically instead of horizontally. I'll click draw boxes horizontally. So this is your box plot to make it look like more of a regular box plot again. Okay, squeeze it a little bit. So here's all the values you have. Here's the summary. Lower limit here is talking about the minimum. Upper limit 98, that's the maximum, and you have Q1 median is the same as Q2, right? So Q1, Q2, Q3.